Factoring integers. You can write 12 as a product of different pairs of positive integers. For example, 12 can be written as 1 times 12. 12 can be written as 2 times 6, can be written as 3 times 4. It all means the same thing. They all mean 12. The integers 1, 12, 2, 6, 3, and 4 are factors of 12. You could find factors of a number by division. Okay? Each division above has the remainder 0. In other words, we would say 12 is divisible by 2 because 12 divided by 2 is 6, and there is not a remainder. 12 is divisible by 3 because that gives us 4, and there is not a remainder. Each division above has a remainder of 0. The integer 7 is not a factor because a factor of 12 because 7 divided into 12 has a remainder of 5. Really not a whole lot that you need to know there as far as what it means to be divisible or what it means to be a factor. Example 1, page 181, express 24 as a product of prime factors. So we're going to take you back to prime factorization, okay, for today. And we're going to revisit the factor trees and come up with just a line of prime factors that we would use to describe the number 24. First step in setting up a factor tree is what? Coming up with, Mark? For example, 6 times 4 is where we could start. Do I have to start with 6 times 4? Do I have other options? Absolutely. I can start whatever I want as long as what it is equals the number on top here. So 6 can be broken down into 2 and 3, both of which are prime numbers. Prime meaning what? It's only divisible by what? 1 and itself, absolutely. And then 4, 2, and 2. Once everything has been circled and nothing can be broken down, how do I write these? Marlia? In order, right? So you're correct. 2 to the third times 3 is what we'd be looking for as a final answer for tomorrow. Because there are 1, 2, 3 2s, and 3. And order meaning 2 comes before 3. All right? Try 50. Prime factorization of 50. Where are we starting, Kate? 10 times 5, that'll work. 10 breaks down to what? Both of which are prime. And 5, prime. 2 times 5 to the second, right? Negative 700. Basically, what we're going to do is for now we're just going to ignore the negative because it's a real quick fix at the end. Let's just focus on the integer 700 and what? Yeah. 70 times 10 works out just fine. From there, from 70, if we go 7 times 10, we can circle the 7 as prime, and the 2 and the 5. That 70 is now done. I can focus on the 10, 2, and 5. Okay? So that would give us, Mark, let's address the negative now. All we'll really need to do in this case is to stick a -1 in front of all of it. Meaning that once it's all done, it's going to end up being negative. Basically, that's the fix. Any questions there? Any questions on prime factorization? what do you do if you get to an integer that looks like it's prime? As you look at 182, look at 182 real quick, and look at 1 through 32. As you look especially at 17 through 32, can you think of something that each of those integers are divisible by? You're not going to get stuck. Okay? Like which one? Yeah, 304 is divisible by 2. Now, where do you go from there? If I'm looking at my assignment and I'm looking at 304 and I know it's divisible by 2, I just don't know what, then by all means you may have to just find out. Okay? Staring at it isn't going to do anything. Remember, you have divisibility rules, but if you look at some of these, 17's even, 18's even, 19's even, 20's even, 21's even, 22 is not even, but how do you know you can divide it by 3, Mark? Good. So we have the tools, the divisibility rules that we can use in case we get stuck. So 230, is it 231, Mark? When I look at 231, it's really easy to look at that and say, oh, that's prime. That's going to be negative 1 times 230. No, hold on. Because 2 plus 3 plus 1 gives us 6, which means it's divisible by 3. Okay? What's the divisibility rule for 4? Remember? Now that we're on the topic. So the rule for 2, obviously even. Rule for 3, you might want to get these down if you don't remember. Sum of the digits divisible by 3. Remember 4, Mark? Yep. Last 2 digits. Does that mean you add the last 2 digits or just the last 2 digits as is? Just the last 2 digits as is. Rule for 5. Yeah. Rule for 6. Because we've been doing these since 6th grade. Right? Like which one? 6? Which one? Were you speaking in one in particular? No. 9? Sum of digits divisible by 9. And obviously 10 ends in 0. So in case you need them, there they are. But that was 231. Look at 23. It's 280. That's even. 24 is even. Also ends in 0. 504. Like 25. It's 504. It's even. You could divide it by 2. But 5 plus 0 plus 4 is 9. You might prefer to just find out where it is when you divide it by 9. So it'll help increase some of your options. Okay. But everything else in there, you should be okay with. Not too entirely worried about it. Yeah? Wait, because we're just about to finish. And then afterwards you can do it. Okay. So any questions there on 1 through 32? I'm not going to assign all of them for you. But what do you do if it's negative? Yeah, you just buy negative 1 at the end and you'll be fine, right? So let's do page 182. 17 to 32.